Hello, everyone. My name is Mandeep Singh Walia. The topic of my presentation is temperatures and wear at railway tread braking. This study involves field experiments and simulations. I'll start off with the outline of the field tests. The tests were performed in urban network, rail network in Stockholm, called as Roslagsbana. The aim of the study was to study the temperatures of the wear, temperatures and the wear of the brake blocks and the wheel, study the temperatures and wear of the brake blocks and the wheel at the revenue traffic. So the temperatures were measured for the wheel web and the wheel tread, along with the brake blocks, and the respective train speed and the axle load and brake pressure was measured. And there was also data measured for the GPS location. Wear measurements were performed for the wheel tread and the brake blocks. The train used for the testing consisted of three wagons: the motor car, middle car, and the driving trailer, out of which motor car and the driving trailer car were used for the testing. The axles pointed here are the one which were used for instrumentation. And one wheel each at these axles were instrumented. So the motor car is the heaviest one from the all of the three, and the average braking pressure is around 3.68 bars. And it's equipped with the cast iron brake blocks. And the braking effort is performed in combination with the electrodynamic brakes and the tread brakes. And for the driving trailer, it's equipped with the organic composite brake blocks, and it has only tread brakes. For the temperature measurement at the wheel tread, initially a sliding thermocouple was used in the setup, which exhibit the high electromagnetic disturbances that time. Another setup after several trials was found where surface thermocouple was glued on top of the sliding thermocouple, which worked quite well. And for the wheel web, there were surface thermocouples attached at the wheel web on the field side of the wheel, and you could see here that there's a plate attached, and the back side is a data logger. And for the brake blocks, holes were drilled into the brake blocks along the radial direction, or you could say thickness. And the thermocouples were inserted into those holes and along with the glue. So the measurements were performed for a route. We have the train speed and the brake pressures and the resulting temperatures. What we could see here that we have quite low temperatures for the wheel, and in comparison, high temperatures for the cast iron brake blocks. We could also see that for the brake block, the temperature varies substantially. If you see here, it's quite low and it's quite high. And it's low in this braking tour, and here it's quite high. So this is probably due to the thermoelastic instabilities, due to localized contact in the wheel block nominal contact area. And for the tread temperatures, it can be seen that sometimes it goes lower than the wheel web temperatures. It occurred due to the tension in the thermocouple wire, which caused the uplift of the thermocouple on the wheel tread. But it worked quite well here in the beginning of the test. For the driving trailer, a similar test was performed, and unfortunately, there was no brake pressure data available for that test, but we had the speed and the resulting temperatures. Here it was organic composite brake blocks. And if you see here, the temperatures were higher for the wheel if we compare as compared to the motor car here. And the temperatures were lower for the organic composite brake blocks. Another thing is that the temperatures for the tread are higher most of the time. And it goes lower at these positions where it's at the standstill, so it's not at the braking, so it works the measurement works quite well here. And you could see that the tread cools quite faster than the wheel web when the train is at standstill. So the next step was to simulate, and for that we begin with the thermal model, where we have an input to the thermal model from the train data. We get the heat flux, and the heat is then partitioned between the block and the wheel. We use an axisymmetric representation of this setup, which is implemented in MATLAB. And we account for cooling by convection and radiation, and also account for the wheel rail cooling at the wheel rail contact. So the temperatures were simulated at the points at which measurements were made. So the simulation results are shown with the thin line along with the marker, and the bold line are the measured values. It can be seen that there is some variation with the measured and the simulation values. It's due to the cause of thermoelastic instabilities. So the thermal model cannot capture the local high variations of the temperature, but it can account for it in an average way. It will be more interesting to see how does for the simulated temperatures for the driving trailer car, because there are no such high fluctuations in temperature were observed. So it will be more interesting in that case to see. Further, the wear for the brake blocks was measured using a high precision weighing scale at the different mileage. If you see, we could get the wear rate corresponding to the weight loss of the block. And further simulation was carried out for the cast iron brake block using the wear equation, where a temperature-dependent wear coefficient was used, which is taken from an earlier study performed. And the result for the calculated wear rate matches quite well with the first value, so it correlates quite well here. So it's a good start, and it can be used further. For the wheel tread wear, the wheel profile were measured using a mini-proof. And in a short analysis of the data, the change of flange height at the rolling circle is described here as the wear of the tread. So for the motor car, it's at the 70 millimeters from the flange side, which is quite obvious measurement from there. But for the driving trailer, the thickness of the width of the block is a bit wider, and also it's positioned a bit more towards the field side. So we have modified this SH value, which is at 80 millimeters from the flange side. So the results are shown for that. It can be seen that the change in flange is quite gradual here in comparison to the driving trailer. For the first two measurements, it looked quite well, but for the last measurement in a short distance, there is a high change. It shows that we need a further detailed analysis of this of the wheel profiles, where we have a detailed analysis of the entire wheel profile. And more measurement data would be quite helpful to study it further. In summary, the motor car and driving car trailer were used for the testing, and the testing was performed for the cast iron and the organic composite brake blocks. The temperatures were measured for the wheel and the brake blocks, along with the wear at the wheel and the brake blocks. And the brake pressure data was not available for the driving trailer car. Simulations were performed for the measured data using the trained data as an input to the thermal model. And the calculation of the temperatures were performed for the wheel tread and wheel web and brake blocks. It was done for the motor car, and also the wear was simulated for the cast iron brake block with the reasonable agreement with the measured value. So now the work is ongoing with the testing, short-term testing, which was recently finished, where the temperatures were measured again for the driving trailer along with the brake pressures. And the next step is to simulate the temperatures and the wear. A detailed profile analysis will be performed where the wheel profiles are measured for the over the wide range of data that will be collected, and simulations will be performed for the wear for both cars. In the last step, it is also ongoing with the measurement. We have the long-term testing measurement where it consists of measuring the train speed and the axle load and brake pressure. And we don't measure the temperatures here, so the idea is that we use this data to simulate the temperature and further simulate the wear. And also we measure the wear along with these parameters. And at the end, we could make a comparison between the simulated and the measured values. Thank you for your attention.